So I'm going to go over question 40 on the third practice test that I handed out. And it is basically how do you hook up a watt meter and a ammeter. So this here is our watt meter. As you should know, like watt meters use voltage and current to determine the wattage used in a circuit. And this, of course, is our ammeter. Not a great like looking diagram on whoever made this test on their part, but regardless, what we need to know is that whether or not you connect things up in parallel or series with the load. So to make things a little bit less confusing, perhaps I'm going to hook these lights up as if they were in a circuit. So we hook up all loads pretty much in electrical and residential and the vast majority of electrical work in parallel so that they have the same voltage and we can hook them up to a source. And we usually use 120 volts. All right. So if we want to figure out the current going through this particular circuit, then we need to hook up our ammeter in series so that's reading the total current of both these two lamps. So let's just make up a value that each of these lamps are using up 1 amp, and so there would be 2 amps on total used up. So we'd have to place our ammeter around or in line in series with this branch here or this branch here that goes back to our source to read the full total current going through this. So we would need to, let's interrupt it right here. And our ammeter is going to go through and back to our lights. And so now that full 2 amps, as it works away around the circuit, has to go through our ammeter and is able to read the total current. We don't want to know the current just going through each individual lights. We want to know the total current. So that's how we would hook up our ammeter. Likewise, we would have to do the same thing with our watt, like the amp portion of the watt meters. So we could interrupt it right here and just simply go through, whoops, let's erase that, go through the ammeter here, and then through that ammeter. So now it's being read through the ammeter of the watt meter and then through just your regular ammeter. Okay. Now, obviously, when you're dealing with an ammeter that connects up in and becomes an integral part of the circuit, you have to disconnect your circuit before you should be doing this. And that's something you should need to know for the meter section of this course. Likewise with the watt meter, because the ammeter portion of the watt meter becomes integral in the circuit, meaning the current's going through that watt meter, then again, we have to disconnect the circuit, de-energize it before we are able to hook things up. But once we turn the circuit back on, now the current has to go through, our watt meter has to go through the ammeter, and we're going to get correct readings. Okay, so now let's deal with the voltmeter so that, again, we can get the watts, and we know that power is equal to I times E, or V if you'd like, and that's how we determine wattage. And so voltmeters, we always hook them up into parallel to read the potential difference between 2 points. And so we could hook it up here between this load here. We could hook it up around that load there. And we can even hook it up across the source here if there is a viable connection. So let's hook up our voltmeter at that point there and that point there. And then again, the wattmeter is just calculating our voltage, and it's calculating our current and then multiplying them together and spitting out the wattage for this particular circuit. So that's all that question 40 is asking you, but please note for the exam, you always hook up an ammeter in series. You always hook up a voltmeter in parallel.